Limiting reactants. All right, the last major part of this chapter is limiting reactants, and you should remember this from Chemistry 1. Another way to say limiting reactants would be limiting ingredients. Which one of our ingredients or which one of our reactants is going to determine how much product can be produced. Let's take a look at a cooking application of this. I always like to associate chemistry with cooking because obviously cooking is chemistry. Okay, in this picture, we notice that we have pretty much a full dozen eggs, a whole gallon of milk, a whole container of flour, and it looks like 2 pounds of butter. We only have a very limited amount of sugar, though. We have just a little bit of sugar. We can make cookies, or we can produce cookies. We can make so many products worth of cookies until we run out of one of our ingredients or one of our reactants. Well, which reactant or which ingredient is going to determine how many cookies we make? Well, it's going to be the least amount. Okay, we can only make as much as our least amount of ingredient will allow us to make. So it appears as though our sugar is going to be our limiting factor, or our limiting ingredient. So once this family runs out of that sugar, then they will have to stop making cookies, or at least any cookies, I guess, that you'd want to eat. You wouldn't probably want cookies with just butter, flour, milk, and eggs, and you'd probably want them to be a little sweet, one would assume. In this example, our sugar would be the limiting reactant because it tells us, or it dictates how much or how many cookies we can make. Well, how does this work in limiting reactants? The limiting reactant is the one that is present in the least amount. Well, how do we determine which one is present in the least amount, and how does that matter to us? Well, we have to perform stoichiometric calculations for each reactant. Stoichiometric calculations for each reactant. Typically in the problem, you will say you're given so much of this and so much of this, how much will be formed? Well, we have to see how much can be formed from each of those starting reactant amounts. We use that information to determine how much product can be made. The least amount of product that is made dictates which one of those plus our limiting reactant. For example, here, I've got 10 hydrogen molecules and 7 oxygen molecules. Well, they're coming together and combusting, if you will, to form water. Well, it looks like I have excess oxygen left over from this reaction. I have 2 molecules of oxygen, or 4 oxygen atoms left over that are unreacted. So here we would say oxygen is in excess. But our hydrogen would be our limiting reactant, because if we had more hydrogen, then we could have made more water. Okay. Now, the theoretical yields. Okay, when working with stoichiometry, this was essentially assuming ideal situations. Okay, these ideal situations give our theoretical amounts. Okay, the grams that we form or grams that we find are our theoretical amounts. Well, we actually are assuming that this reaction is occurring 100%. Well, that might not necessarily be the case. We may not always produce that much or that many grams of a substance. Okay? This is different from our actual yield. What we actually produce would be considered our actual yield. So how do we talk about how good our reaction was or how efficient our reaction was? Well, we talk about that in percent yield. Percent yield compares our actual yield and our theoretical yield. Okay? Our actual yield and our theoretical yield. Percent yield is actual yield divided by theoretical yield times 100. Okay? And that's going to give you a percentage. Your percentage on a percent yield should be very, very high. Okay? That's going to be the best case scenario. It should be very, very high. The higher percent yield, the more efficient your reaction was. So the actual amount is the experimental amount, or the amount that you actually find, divided by the theoretical yield, which is what you calculate stoichiometrically, times 100.